Morning class, we are doing physics chapter number 7, electricity and magnetism, and we are on the topic principle of an electromagnet. It says, children, if an insulated copper wire is wound around a cylindrical cardboard, then we get a cylindrical coil, children, and it is called solenoid. When the ends of this coil, children, the ends of this coil are joined to a dry cell and current is passed through it, then this cylindrical coil, which is carrying current, it behaves like a magnet, means it produces a magnetic field around it, and this magnet is called an electromagnet. Now children, the magnetic polarities at the ends of the electromagnet depends on the direction of current in its coil. Like we have two poles on a magnet or a piece of magnet, one side north, one side south. But how to decide the magnetic poles in this? So we take the help of clock rule in this. This clock rule says that the end of the electromagnet where the direction of current is anti-clockwise, it becomes north pole, and the end where the direction is clockwise, it becomes south pole. Clear class? Then comes, if you want to increase the magnetic field of an electromagnet, then what can you do? By inserting a rod of soft iron or steel inside the cylindrical tube, this rod is called the core. You can increase the magnetic field by inserting what? A soft iron or steel, children. Secondly, if you increase the total number of turns of the coil, then also the magnetic field is increased. And finally, if you increase the strength of the current, then also the magnetic field of an electromagnet can be increased. And also children, there are two types of magnet: temporary and permanent electromagnet. For temporary electromagnet, we use soft iron as the core, and for permanent electromagnet, we use steel as the core. Please note down these 2 points. Now children, we come to making an electromagnet. Now we all know that electromagnet is a temporary magnet, because children, why? Because it acquires magnetic properties only when current flows through the coil, and loses the magnetic properties as soon as the current is switched off. Only it is having the magnetic properties when the current is flowing through it, otherwise not. So children, in this temporary magnet, it consists of soft iron piece on which a coil of insulated wire is wound, and the ends are connected to a direct source of current like cell or battery, which we have just seen in this diagram. Okay. Now children, usually electromagnets are made in 2 shapes: eye-shaped like this, and the horseshoe magnet like this. In this, the copper wire is wound around this bar, and here the copper wire is wound around this horseshoe, or you can say U-shaped magnet. Clear class? Now children, what are the uses of electromagnets? Electromagnets has got many uses. Mainly it is used for separating magnetic substances such as iron from other non-magnetic substances, and besides this, we also use it in electrical gadgets like electric bell, electric tram, electric motor, microphone, loudspeaker, etc. And the very important application of this electromagnet children is electric bell, which is used. You can see outside every house there is an electric bell, so there we use it. Please learn this diagram properly. Okay, learn to make this diagram of this electric bell. Now we come on the topic Earth's magnetic declination. We have read that our Earth has a magnetic field of its own. We all know that Earth has a magnetic field. This you must have studied in geography also. This is why a magnetic needle, when freely suspended, always rests in the north pole direction, and this is the reason the magnet has got that directive property, that always magnet rests in north-south direction, which we have read in our first video. So the Earth's magnetic south pole is geographic north, and the north pole is in the geographic south. Since children, unlike poles attract, therefore north pole of the suspended needle is in geographic north, while south pole is in geographic south. Understood this line, children? Let me read it again for you. The Earth's magnetic south pole is in geographic north, and north pole is in geographic south. Now, because we all know that children, unlike poles attract each other, therefore north pole of suspended needle is in geographic north, which is actually what? Magnetic south, and the south pole is in geographic south. Okay. Now actually the north pole of the suspended magnet is not exactly along the geographic north you can see in the figure. Now let's read the definition first. Magnetic declination is the angle of the horizontal plane between the magnetic north and the geographic north, or true north you can say. This angle is shown in figure 7.12 by the symbol theta. You can see this diagram, children. This is your geographic north and this is your magnetic north, and this is your angle theta, class. Now children, this angle of declination is different at different places on Earth's surface, and it also changes at a place with time. At same place also it keeps on changing with time. Now this is taken positive if the magnetic north is towards east of the true north, as in figure 7.12, and is negative if the magnetic north is towards west of the true north. Now we come to use of electricity and its sources. We all know, children, in our daily life we use electricity in many different ways. To light our home, school, office, etc. To run the fan, television, heater, radio, etc. It is used to run movies in cinema hall, to run machines in factory. There are many uses, children. We use a number of appliances. You can see in this diagram, in this figure, there are many things which we run through electricity. Our homes which run on electricity. There are many appliances that are home also. Few electrical appliances are shown that I have already shown you. Now, what are the sources of electricity? From where are we obtaining? We are getting this electricity. We get electricity from electric cell or battery, mains, generator and solar cells. Now, one by one we are going to read all these things. Now, first comes electric cell. An electric cell is the most common source of electricity. This is the most common one. A cell consists of a vessel. There is a vessel which with two metal rods. There are two metal rods called electrodes and a chemical substance, either in the form of solution or paste. You can see this blue na? It is a chemical substance. It can be solution form or paste form, and it is called electrolyte, children. Now this is a simple cell which you can see in this figure. Now children, in a cell what is happening actually? A chemical reaction occurs only when it is used to a chemical reaction occurs when it is used to draw current. Okay, when you want to take current from it, then only a chemical reaction will take place inside it. As a result, what happens? Chemical energy is changing into electrical energy. Now this chapter 3, remember, chemical energy changes into electrical energy. This is one example of that. Simple cell is one of the example of that, children. Okay, you can relate this chapter to that one. And the cell becomes what? A source of electricity. Copper rod becomes positive electrode. This copper rod will become positive one, and it is called anode, and zinc rod becomes negative one, or you can say cathode. The most commonly used cell is the dry cell, and it cannot be recharged, children. You cannot recharge it again. Once it is used, it is finished. Now dry cell. A dry cell consists of a zinc container whose base acts as the negative electrode. Now its base acts as the negative electrode, or you can say cathode. It has a carbon rod at the center with a brass cap. Okay, and the carbon rod acts as a positive electrode, or you can say anode. Positive electrode, children, anode, and negative one as cathode. The rod is surrounded by a mixture of manganese dioxide. Now all these words you must have read in your chemistry also. And charcoal in a muslin bag. The electrolyte used is mostly a paste of ammonium chloride. The electrolyte, this kind of solution which we are using in this one, is mostly mostly it is a paste of, children, what? Ammonium chloride or plaster of Paris or flour, etc. The outer body, except the base, children, except the base of zinc container, is insulated with a thick cardboard or plastic material. You must have seen a dry cell, children. Please see this diagram also. Now when the cell is connected to a bulb, the chemical reaction takes place and current flows in the circuit from the anode of the cell towards its cathode. Anode positive, cathode negative. So from positive to negative through the cell, and the bulb glows. Now what are the advantages, children, of using this dry cell? First of all, they are light in weight and small in size, and they can be easily carried. They are portable. They can be easily carried from one place to another. Secondly, there is no fear that they can have any leakage or something, because they are dry cells. They can easily be used to run simple electrical devices. You can use them to run simple devices. Okay class. Now, do you know children, the dry cell has two terminals labeled as plus and minus. The positive has brass cap at its top, whereas negative is the can at its bottom. Now this is the diagram showing two terminals of a dry cell, positive one and negative one. Positive one has brass cap at its top, you can easily see this thing, and negative one is the can at its bottom. Now use of dry cells in a torch children. We use dry cells in a torch as the source of electricity. Have you used torch in your life children? You must have used, yeah, है ना? So we use what? Dry cells in that. Now these cells are joined such that the brass cap, that is anode of one cell, is in contact with the container, that is cathode, of the other cell. Now they are kept in such a way that children, anode of one cell is in contact with the container cathode of the other cell. Anode of one cell is in contact with the cathode of other cell. Now figure 7.17b, it is showing the outer case of the torch. Now this was the inner thing which they are showing the internal. Now it is showing the outer case of the torch. As we press the switch on, what happens? The torch lights up. If we take out the cells from the torch, then press the switch, it will not give you the light. Now this shows that cell is providing electricity to light a torch. Without cells, the torch is useless. Now children, use of dry cells. We use dry cells as a source of electricity in many appliances: radio, tape recorder, bicycle lamp, car headlight, television set, calculator, wristwatch, transistors, and many more things. Now next comes children battery. What is a battery? If we use a group of two or more cells, it is called a battery. A battery is used where we require more electricity. You must have seen a battery at your house children. It is nothing else but it is a group of two or more cells children, and it is we require it when we use it when we require more electricity. Now what to do to form a battery children? The positive terminal of one cell, is kept in contact what? With the negative terminal of the second cell. Then the positive of the second cell is in contact with the negative terminal of the third one, and so on. You can see in this figure 7.18. The bulb or appliance with which the battery is to be used, for which appliance we are using this battery, is then connected between the negative terminal of the first cell and the positive terminal of the last cell. Whatever thing you want to run with the help of this, you put it between the negative of one and the positive of the other. Okay class? Now beautiful thing we need to know today is that children, dry cells are actually not dry. In fact, a dry cell works only as long as the paste inside, that electrolyte na children, it remains moist, गीला रहता है. The presence of water moisture helps in the movement of the ions, because this moisture, it is helping the ions to move inside the cell from one electrode to the other. If the cell has not been used for a long time, then it stops working because the chemical present in it are spent and it stops producing electricity, and then it is called a dead cell. Till it is working, the moisture is there inside it, it is called a dry cell, and it is working. And once it is, this thing becomes dry inside and it stops working, then it is called a dead cell. Then comes the mains. Now this will take in our next video. Please read till here. Thank you. Have a nice day.